All right. So with a small delay, but thank you all for showing up for today's webinar. Today we'll be talking about APIs and events, especially how to combine them, and we'll look at a few use cases for real-time banking. So my name is Jeroen van Disseldorp. I'm founder and CEO of Axual. So let me also quickly introduce Axual. We are a software vendor that was founded in 2015, venture capital backed. The team consists of around 50 Kafka experts across the EU. We are mentioned by Gartner as a representative vendor in the Kafka space. We have security certifications. Our headquarters is in Utrecht, and today we'll be talking about financial services companies working with Kafka, working with events. So it's also nice to know that we are an approved cloud provider by the European Central Bank, and we can offer cloud services to any company that is operating in this space. We've done many different Kafka implementations already at different companies. We won't be discussing those today. Today we will be looking at where to position APIs and events exactly, when to prefer one over the other. Financial use cases using events, we'll zoom into how that is done in specific cases, and then challenges of event platforms that we see in the market, and of course, what you should do next after visiting this particular webinar. So let's jump right in. So this will be jumping right into the content, how to differentiate APIs and events. If you look at APIs and events, there are typically three ways to organize processes getting triggered in bigger organizations. The first one, well, we kind of plastically compare them to systems in the human body. So the first way to trigger events is time-based. This is really comparable to data warehouses, data lakes that work with big data sets, which are typically triggered a number of times per day, or maybe once a day, when new data came in. And this is like sort of comparable with your digestive system. Because you eat 3 times a day, you eat in batches, you eat in quantities, and the whole process is fairly slow but predictable. So that is a way to trigger an event, to trigger a process, time-based. The second way to trigger a process is what we would nowadays call API. This used to be service-oriented architecture or web services or SOAP. Nowadays, it's all called API, and we have a bunch of different standards that implement it. This is typically comparable to the client-server pattern, where your brains are the clients and all of your muscles form the collective set of servers that you have in your body. Where the brains continuously send, commands to all your muscles to contract or relax. Those would be the most simple instructions that they can give. This means that there are client servers, so it's 2 involved party individual commands, millions of signals per day. But the most important distinction between this pattern and the other two is that your brains have a specific intent of what they want to accomplish with your body. So a particular muscle has to obey, it needs to contract or relax, but there's an intent. You want to move, or you want to blink, or whatever you want to do. Your brain has an intent of putting that muscle to work. This is very different again from the next pattern, and this is event-driven architecture. Where you have millions of signals per day coming from all the sensors that you have in your body. So this could be the receptors in your finger, it could be your balancing organ, your eyes giving visual stimulations to the brain. So all kinds of signals that you receive in your body that are put on your nervous system, and then are delivered to basically all parts of the brain that have an interest in receiving those signals. So this also concerns millions of signals per day. It's individual observations that are communicated. There's contextual processing taking place because your brain is in a particular context. And although many million signals are delivered every day, most of them are completely ignored. So if you're now happen to be sitting down while looking at this webinar, you may not notice the fact that you're sitting on a chair, but once I start talking about it, all of a sudden your brain becomes aware that you're sitting on a chair, and you start feeling the pressure that you exert on your chair. Whereas just a moment ago, you weren't even aware because you were mostly following the story. Contextual processing is taking place quite heavily in your brains. If you wouldn't have that, then you would basically go crazy because it requires a lot of processing then. It's like a collective network of systems that together make up the entire intended set of functionality that you want to have executed. So what sets these three systems apart? Well, basically the first one and the third one are data oriented, whereas the second one is really command oriented. In data warehouses and with event-driven architecture, you really talk about the data, data contracts, what does the data look like, what does it mean, etc., etc. Whereas with APIs, you talk more about what does the command intend to accomplish. So there's execution logic that you trigger by calling an API, and you happen to have to transfer data in the context of executing that API. But it's more or less an afterthought, because if the API doesn't require any data, either because it's stored already locally or because there's no parameters to pass along, it's really all about the command execution itself and not about any data transfer. So hopefully this makes a little bit of sense. Sometimes people ask me, now that we have event-driven architecture, is everything going to move to this new way of thinking or to the new types of implementation? And then there's a nice analogy in this comparison, because if any of these three systems get removed from your body, you die. And that's the same for organizations. So if you don't have data warehouses where you can do reporting, where you can do all kinds of analysis, if you don't have APIs, or if you don't have events, basically you would not be as efficient or as alive as you are when you have all three of these. Okay, so when to prefer one over the other? And for the rest of the story, we will be ignoring the first one. Data lakes is pretty common, and we're not diving into that today. We will be mostly looking at the distinction between APIs and events. So when to prefer one over the other, when to prefer events, or when to prefer APIs. So let's look at a small example from the mobile banking world. So suppose we have a customer that uses a mobile banking app. With that app, we want to initiate a payment to transfer some money to some other bank account. So the customer does an initiate payment on his mobile that then in turn calls the bank API. The bank API does a validation. Is this a registered mobile app? Is this customer allowed to call this API? Well, if all of those are passed, then the initiate payment instruction is then sent to the mainframe, where a new order gets executed. A new order gets created. Now, depending on how you design your API, you may already return the fact that you have accepted this new order. It wasn't executed yet, but you've accepted this new order. That may be a result that the API can give you. But let's suppose that we don't do that right away. Let's suppose that we execute the order as well, and we send back the execution result. So not only just that it executed, but also whether it was successful or not. Okay, so far so good. But now, once the transaction is executed, then a lot of other things come to mind that also need to be executed. So, for instance, most banking apps, they have a separate cache for holding all the transactions that took place. Of course, those transactions are also kept on mainframe, but if all mobile banking apps would be querying the database on mainframe, those would get completely overloaded. So most banking apps have a cache somewhere sitting in the organization from which all the timeline queries for the mobile banking apps are served. So that cache needs to be filled. Also, we need to do alerting for customers that have configured to receive alerts. We need to do fraud detection. Many banks, they also have accounting packages that they offer to their clients. There's personal finance management to give insights into what kinds of categories your spend is in. And there's obviously many management information dashboards or other types of dashboards that can provide insight to either the customer or to bank employees or maybe to bank management to get an overall view of what is the current status and the current financial status. Now, so let's suppose that we want to notify all these applications through, well, some sort of an API. We don't know what it is, but it's some sort of an API that will notify all these applications. This means that because APIs are request and response, that mainframe will then, well, visualized here through some sort of an API. This can be a direct API on timeline itself, would notify timeline of the fact that this transaction got executed. Now, exactly because this is client server and this is a one-on-one pattern, this would imply that we need to send all these applications a specific notification about the fact that this transaction took place. But this, of course, leads to very bad system behaviors. Because now, all of a sudden, because of this pattern, mainframe needs to know all its consumers. Calling other systems is not core banking. Failure scenarios are infinitely complex. If consumer 3 here were to not be available, and consumer 6 has some downtime, that would lead to retry scenarios, and well, that can get very, very complex soon. And of course, well, as you can count on the arrows, we see that new order and execute, that gives you 2 operations to execute a transaction, but we see already 6 operations that are required to do the notification to all the derivative systems. So the communication becomes much heavier than the task execution that we expect mainframe to be doing. So ultimately, this is, well, pure agony if you implement the notifications like this. So, let's look at how this would be implemented if you put Kafka in the middle. Then you still need to do the notification. So now mainframe would notify Kafka about the fact that the transaction took place. And then from here on, this will act as a sort of like an announcement to the rest of the world that this transaction took place. And now all consumers of that particular transaction can just get the information directly from Kafka. This gives a much better picture than the picture before, because now mainframe doesn't need to know all its consumers. It becomes really a fire and forget to notify a single system about the transaction that just got executed. It's much simpler, and the communication is much lighter. So you can really concentrate on executing your core banking processes. Now the division between work and notification is really 2-to-1 instead of 2-to-6. So that's really a good improvement. So quick summary, when to prefer APIs over events. It's really when you want to request another party, probably a specific party, to do something while being prepared to wait for the reply. Often these calls are synchronous, so while I call somebody else in that same TCP connection, often we get the results of the API back. So it's synchronous processes called by somebody with a specific intent. And in our example, the customer, the bank API, and the mainframe, these are perfect examples of where APIs really work well. And this results in a many-to-many network of interactions, because you can have many clients, you can have many APIs served out by many different applications. So in practice, this is usually resulting in a pattern of many-to-many interactions. So when to prefer events over APIs? Basically to set in motion everything that needs to happen which was not part of the original API's intent. So if I'm a customer and I send a mobile banking, or as I instruct my mobile banking app to initiate a payment, then my intent is to have money transferred to some other bank account. And my intent is not to trigger all kinds of processes that I don't even need to know about. So timeline, alerting, fraud, I mean, this is all not in the intent of me transferring money to somebody else. But these processes, they do need to be triggered. And this is done asynchronously, triggered by the data changes, in this case, the transaction that took place and the money being deducted from my payment account. So when you wire up your IT landscape like this, it's really like designing a big if this then that system for business. So if a transaction took place, then I need to update my timeline, I need to update alerting, I need to update fraud, etc., etc. I hope this also makes sense. Let's look at a few financial use cases for using events. Well, this is a bit of a personal history that we have with a number of our banking customers. So if you have an event platform and you start putting this as a central hub in your organization, positioning it like that. Well, initially in 2015, we started out with a use case where we took payments from mainframe and we did payment alerting on payment accounts to all customers. But soon after, the next department that came along that was also interested in these payments was the personal finance management department, because they had a big machine park that categorizes all transactions between 12 a.m. and 6 a.m. So basically they had a time window of 6 hours during the night in which they had to categorize all transactions. And they absolutely had to guarantee that by 6 a.m. they would be done, because that would be the moment where, you know, the data was exported back into the systems that got queried during the day for the transaction timeline. And so if you're not ready by 6 a.m., your categories will not show up in the customer's mobile banking app. So they had a quite oversized machine park, but now they said, well, you know, this payment information, yeah, what if this comes in a streaming fashion? I don't need to do the processing in batch. I can just, you know, spread my loads that I now have through the 6 hours. I can spread that across 24 hours. And not only can I reduce the machine park itself, but customers also get their categorization quickly. So that's much more preferable to having it executed as in a batch fashion during the night. Then, of course, savings department came along. Can you also do, you know, the alerting on savings accounts instead of only payment accounts? Investment came along and said, well, if you're going to do alerting, we can also use that, because we want to do alerting on stock orders being executed or being expired. Then an interesting discussion started going, because the mortgages department had a customer that did a risky investment while also having a back payment on their mortgage. So the mortgages department said, well, I'd rather have that they pay off their mortgage first before entering into a risky investment. Then marketing came along and said, well, all of these, you know, payments, savings, investments, that's all interesting for us to get a better view of the customer, to be able to advise in the right products and services. But it's not only those transactions that got executed. It's also, you know, the alert settings and maybe even also the categories that people are spending their money on. That's also insightful for us to get to know the customer better. The only thing that is still missing is the clicks on the websites, because ultimately we'd also like to follow the whole customer journey, being able to estimate, you know, where customers are triggered and where they go away from our website to understand what our offering, what makes our offering interesting, and where people leave our websites. So could you also add those clicks? Well, you can imagine that this was a really interesting discussion. which took place over a number of months. But it was clear from the start that if you position an event platform as a central platform in your organization like this, many departments will have an interest in either producing or consuming the events of other departments. All right. And there are many more financial use cases that we see in practice. So this was an initial set of use cases that got us going, but there's many more use cases. So all kinds of process decoupling use cases, device registration. If you download a mobile banking app, often you have to register it on your specific device. There's card activation. In the past, you had to dial a phone number to activate your credit card that you received in the mail. And what you didn't know is that behind the scenes, your card number got added to a batch job that got executed in 12 hours. So once you put down the phone, you want to pay with your card, it was activated. No, you're under the impression it got activated. But in fact, you're in a waiting list to have your card activated. Nowadays, this is all instant. The card activation takes place, and the activation itself is notified to all authorization systems in the bank that need to know about this, and they can authorize transactions an instant later. So many more examples here. We don't have time to go in depth on all of these, but if you have any questions, then let me know at the end. But these event platforms, if you want to have them deployed as a central platform in your organization, there are a number of challenges. And one of the most prominent challenges that we see nowadays is the fact that the front end of your organization is organized quite differently from the back end of your organization. So front end, everybody nowadays does DevOps or Biz DevOps, or any kind of agile way to serve the customers, which means that every team has their own target group and has their own target customers that they serve. So you could say that the front end of organizations are the front ends are quite well distributed, whereas the back end is really platform oriented. So there everything comes together, and you want to support your development teams in the best way possible. So what kind of generic tools and platforms can you give them to really develop their business logic faster? And these two don't quite match, because if you have a distributed front end and a singular back end, well, basically you have two types of options to implement that the back end. One is to open up everything, and of course this is what LinkedIn had initially. Where Kafka got developed, there was no authorization, there was no permission system. Data got just dumped in a big basket, and everybody could grab any kind of information. So opening up everything is, for particular organizations, is definitely an option to get all teams to integrate on a common event platform. Nowadays, for banks, this is totally out of the question, because we have many compliance laws, regulations to adhere to. So in terms of, just providing all data to everybody that is interested within the bank is definitely a no-go. So the other alternative that you have is then to implement a multi-tenant platform. But multi-tenant platforms have, challenges of their own, because often what we see is that if you want to have a multi-tenant platform, you definitely need things like data governance, self-service, and security, to just name a couple of topics that you need to cover. And this is exactly one of the challenges that we often see in the growth path of organizations that adopt Kafka in some way. Initially, there's like incidental agreements on the sharing of events between applications. So this could be done over MQ, or this could be done in any other way. At some point, it makes sense to have a broker put in the middle. This is often called like a project level Kafka, where a team sets up a Kafka implementation and supports this for 2 or 3 teams around that particular team. That project level Kafka often does not have very good security. A few corners are cut, and there's often a team that maintains that particular Kafka installation. But as you see 5, 6, 7, or 8 Kafka implementations pop up in the organization, then somebody automatically starts to wonder, couldn't we have like this central Kafka implementation set up? But as said in the previous slide, to have that as a central platform, you need a number of serious capabilities in that platform. And this is why often when implementing such a centralized platform, organizations get stuck. Simply because it's relatively difficult to set up data governance and security rules and all that on a common platform like Kafka. And this is usually the phase where we come in. So we actually allow organizations to scale around a Kafka implementation. We do that by making a strict distinction between what we call technical maintenance and the functional maintenance. So technical maintenance is done on the streaming platform. This is where you define a Kafka cluster or potentially multiple Kafka clusters that synchronize their data. And this layer is maintained by a technical maintainer. So the operations part is completely covered by this person or this team. Typically somebody with Kubernetes knowledge, able to restart a containerized application, able to read a Grafana dashboard, watch for disks running full, etc. Typically somebody that monitors for performance and availability of the entire platform. But not somebody that is involved with data definitions, because that is completely shifted to teams, individual teams that log into a data governance layer. Through self-service, they can functionally maintain the platform. So, for instance, if you have a role of data owner, you would be able to log in and define a topic, and you can then attach data format. So, in Kafka terminology, that would be schema to your individual topic, and then somebody else can log into the system. That person can be an application owner, register his application. And as soon as that application is fully set up, its credentials are known to the platform, then you can request access to a particular topic, and then it's up to the data owner to either approve or deny. And as soon as you approve, then everything on Kafka would be automatically set up for you. And from that very moment onwards, the application would have access to the topic. This is a very simplified way to talk about what data governance entails, but this is one of the core flows that is supported by the data governance layer. At the same time, these teams, they still write their Kafka applications as you would normally do. So these could be your producers, your consumers, and your streaming applications. But of course, there's also a development process that we fully support. So there's a fully functional API that allows for CI/CD pipelines to change any data in the data governance layer. And there's also a Terraform provider with which you can have your own definitions in your own team Git repository. And then Terraform will deploy it for you into the data governance layer. And from there on, it will be deployed further down to Kafka. But here you see that the data governance layer is more or less used as a compliance checking layer, which makes sure that if there is already an existing topic and if there's already a data owner associated with the topic, nobody else can just claim ownership to that topic and change or update any of its configuration. And this is also key to not only giving responsibility to data owners in the organization, but also to ensuring that they remain in full control of what happens to their topic and their configurations on Kafka. And basically what we say is that, if you have a streaming platform, that's very nice, but without the data governance layer on top, you just have a streaming platform. And we think that, financial institutions especially, they need a enterprise streaming platform that not only scales their data, but also scales the whole organization around that data platform. If you want to see some more videos on this and how we do data governance, check out our YouTube channel. There's a lot more information to find there. So how do we relate to Kafka? Well, simplified is how we relate to Kafka is what Red Hat does to Linux. We take open source off of the internet. we package it, we make it visually attractive, and we make that into one big installable platform that you have regular upgrades for. So it's really a common off-the-shelf platform aimed to larger organizations that want to have a DevOps way of working around Apache Kafka. So coming to the last point on the agenda, what you should do next. So of course, if you get back to work tomorrow, what to do next? Well, I think the first thing to do is if you don't have a clear distinction between synchronous and asynchronous processes in your organization, make that distinction. And then also try to see, what makes sense for implementation. So validate the current implementations of these asynchronous processes, because there's a fair opportunity, a fair chance that the current way of working around events is implemented in a different way than through an event platform. Of course, then you need to decide on how to do the implementation pattern for eventing specifically. So the way that you do things today, is that still the way that you want to do things tomorrow? And for some organization, it makes perfect sense to convey events over APIs. Their load is not so big or their landscape is not so complex. But as organizations grow and the complexity grows, it definitely makes sense to look into event streaming platforms. Now, then the question, of course, is if you got Kafka or not. Well, if you do not have Kafka, then I suggest that you contact Axual to avoid getting stuck while implementing, especially if you want to deploy it as a central facility in your organization. Well, if you already have Kafka, then you can also contact us to just supply the red layer that I just showed you in the previous slide. And we'd be able to put that red layer on top of any existing Kafka that you may already have. All right, and that brings me to the end of the presentation. So thank you very much for joining today. And let's see if we have any questions. Joey?
Perfect. Yes, perfect, Jeroen. Thank you very much. I already saw a couple of questions coming in. I do think, Jeroen, that's maybe easier if you open up the Q&A box yourself. I mean, I can read it out loud, but...
Let me see where to find that.
Otherwise, I can talk you through it.
Here. So if you were to read it, I can.
Sure. A question: how do you see the merge between APIs and events? So exposing streaming APIs to customers or business partners.
Yeah, that's a good question. So thank you very much for that. I think the question is, do you want to exchange your events with business partners? We have a couple of customers that have installed their streaming platform like on the border of their organization, which means that this would open up the door to exchanging information with business partners. So you could allow your business partners to produce events directly on your platform, or maybe to consume events directly from your platform. And this is a very valid business case, or very valid use case, as long as you, can guarantee that the security of your data is adhered to. So the governance of the platform is then mostly with the organization itself. The business partner is provided with access credentials and with endpoints for accessing the topic and the data that it wants to access. But basically, they don't do any modification of the configuration of the platform. They only interact with the data itself and not with the configuration of the platform.
All right, good one. Next question: what about the vendor lock-in with Axual?
Yeah, what about it? So that depends on what levels that you want to talk about. So this is something that we see quite often. If you are worried about being locked into the Kafka layer, we have guarantees that if you were to not find Axual such a terrific party after a contract of a year or 3 years, then we always can discuss an exit scenario, ensuring that your operations are completely set free from any vendor lock-in that you may think you have. So the bottom part of our platform, so that white layer that I showed in the picture earlier, this is a completely open source layer. So if we only do packaging on that, we don't do any modifications on this. So if you want to continue with all the open source components in the streaming platform layer, by all means, this is something that we can contractually arrange. At the data governance layer, that is a proprietary part of Axual. So this is something that you will then have to let go, but there's probably other tooling that you then prefer by that time to replace us with.
Cool, good stuff. Next question. How many Kafka connectors does your platform provide, and how easy can I connect my systems to it?
Yeah, that's something relatively easy. We didn't have a demo in this particular webinar, but there is a self-service UI through which you can define your applications. So those applications can be of different types. You can have your self-built applications in Java, .NET, or any other language. Those can be registered, and we see those applications as black boxes. So you, as the team owning that application, would be responsible for running it and for starting and stopping it. It's done on your own platform. You also have the application type connector, which allows you to select one of the connectors supported by Kafka Connect, and you can have your own connectors or a set of standard connectors. These are visible then in a drop-down list. You can select a connector and you can configure your own connector. Once you do that, the team that does so automatically becomes the owner of that particular integration. So not of the connector itself, but the connector is just a system module that is able to integrate. But it's suppose that you want to integrate topic A with a system B, then the team configuring that would be responsible for the data offloading of topic A to system B. Whereas the team next to that could be responsible for offloading topic C to system D. Those could be the same connector or different connectors, or but it's important that teams themselves can take the functional responsibility of setting up that connector in the proper way, and to start and to stop that connector. And then it's up to the technical maintainer in this picture to ensure that the connectors that are started are monitored and also restarted if necessary. But here as well, there's a separation then between technical maintenance and functional maintenance. So the technical maintenance, the restarting upon crashes is done by the maintainer, but the functional configuration and making sure that it works and actually putting the connector into production, that is what the teams themselves do.
Okay, I see another question coming in. Isn't Kafka replacing most of the time-driven integrations? So how much file integration remains when you have a real-time alternative with Kafka?
Yeah, good question. Well, some interfaces between different companies, they often rely on the fact that you do file transfer, but how you want to handle those, the records in every file internally, that is completely up to you, of course. So in the past, this also used to imply often that if you import a particular file or you export a particular file, that this is also the unit in which the counterparty delivers that information or consumes the information. But if you consume a file from some other party, you may as well just chop it in pieces and produce every record individually on a Kafka topic and have it handled from there. But suppose that we were just talking about the integration patterns and files having also a particular meaning. If you were to chop up your file and put it on a topic as individual messages, what you may lose, and that's of course how you put it on the topic, but what you may lose is the coherence between all the records in that file, because all the records in a file may represent some sort of a completeness of all transactions that happen during a day. And if you were to chop that up and put it on a topic, of course, you can handle those transactions individually, but you would lose the context or the guarantee of having all these transactions complete. And that is often what is required for reporting use cases, where the reporting itself just assumes that there are no duplicates of messages and that there is a complete set of messages in a file to be able to generate the right reports.
Okay, I think that's it for today and that we run out of questions. So I wanted to thank everyone for joining us today, and for sure I will share the recording afterwards, and I hope to see you at the next event. Thank you, Jeroen, for the presentation, and catch you next time.
All right, thank you, everybody. Have a nice evening.
Bye-bye.
Bye.